How you doing? I'm your man, John Wilson. Today we're doing module 9.3. We're going to work with rotation. Specifically, we will understand how to perform rotations of figures on a coordinate plane, identify rotations, and then rotate figures algebraically using coordinate notation. As for the graphic part of a rotation, that is mostly visual. When you rotate figures, primarily you will be using algebra in order to correctly identify the points. And once again, as long as you know how to multiply a number by -1, you should be fine. I'm sure some of you are thinking, well, if we just multiply by -1, isn't that just a reflection again? Obviously, there's going to be one more little catch to it. We're going to have to do a little multiplication of -1 and maybe a little switch. We'll get to that at the end. Right now, I want you to once again understand that we are dealing with rotations. When we deal with rotations, does the size ever change? No. Does the shape ever change at all, anywhere?
No.
Never. Orientation will always change, and once again, the position will change sometimes, because if we rotate a figure around the origin 1, 2, 3, 4 times, we end up where we started. Therefore, technically, nothing changed. So, transformation or rotation is known as a turn. Notice that we are not changing the shape at all. It's a turn. The image has the same size and shape, but a different orientation than the pre-image. I know you saw this slide before, but I just keep reinforcing this over and over and over to make sure that you understand that in all three of these transformations, the size and shape of the figures are congruent from the pre-image to the image. Yes, you've written this in before. Yes, you've seen this before. Congruent is very important, especially when we move into Module 10 that specifically deals with congruency. Now, the length of all the lines, the perimeters, the volume, and the measures of all angles of these figures will, anybody know what goes there? What goes there? Let me ask you a question. Does the length of the lines change when we rotate, reflect, and translate? Yes or no? Does the perimeter change? No. What about the volume? No. What about the measure of all the angles of these figures? Any of that change? No. So what do you think goes there, Mickey?
Will stay the same.
Will stay the same or will remain the same. So yeah, length, perimeter, volume, and measure of all of these angles will remain the same. That is important when we start dealing with congruency. Just remember to write that in. So they will remain the same, which means that, let's just say, quickly, for instance, just pretend there's nothing you're going to write here. Just pay attention. So we have a figure here, and let's say I take this figure, and I'm going to rotate it 90 degrees around the origin. Here's my origin. If I rotate it 90 degrees, it'll end up in this quadrant, and it'll kind of look like it fell over. You with me? Because we're rotating the figure around. If I rotate it here, it's going to look like that. Rotate it one more time. Just giving you kind of an idea of what it'll look like. Now when I rotate it, if this is line x, y, then when I rotate it, this would be line x, y prime. If this is 4 inches, how long is this?
4 inches.
4 inches. This is a rectangle. So let's say who remembers geometry. This is a rectangle, right? What's the degrees of that angle? This is a rectangle. Anybody remember?
90.
90 degrees. So if it's 90 degrees here, what angle here is congruent to x? X prime. And it'd be the same thing, 90 degrees, 90 degrees, 90 degrees, 90 degrees, so on and so forth. You get the idea. As we go from pre-image to the image to another image to another image, we go from prime to double prime to triple prime. All the lines remain the same length. All the angles are congruent, all the lines are congruent. The perimeter, if this was 4, 8, 8, and 8 on 4. Anybody tell me real quick math, what's the perimeter of this figure?
32.
Nope. Perimeter. Come on.
24.
24. So if the perimeter here is 24, what's the perimeter going to be here?
24.
And here?
24.
And here?
24.
What about the volume? What's the volume here?
I don't know.
Can we do the volume of a two-dimensional figure?
No.
No, we can't do the volume. We can do the area though. What's the area?
32.
32. So if it's 32 square inches here, what's the area going to be here?
32.
32 square inches. And here?
32.
And here?
32.
And if we made it three-dimensional, let's just keep on our thinking caps here. If I made it three-dimensional, let's say that this is 3. Can somebody now tell me what the volume is? Anybody? Somebody said it. I think I heard it. Everybody got the volume? 96, right? 8 times 4 times 3. 8 times 4 is 32. I now gave you the width. That makes it 96. So, If it's 96 cubic inches here, it's 96 cubic inches here, and here, and here. None of that changes. But let's see what these look like when we're actually working this. Just so you don't get filmed here. So grab your stuff, sit there. All right, let's see what it looks like. Now, although a figure can be rotated any number of degrees between 1 and, what's the maximum number of degrees we can rotate a figure? Anybody have an idea? 360 degrees, because that's a full circle. Even though we can do that around any fixed point, for this lesson and in this grade level, we're going to be rotating all the figures specifically around the origin, and we're going to be rotating them in one of 3 different ways. In order to know how we rotate a figure, you need to go back to maybe 6th or 7th grade when you first started seeing the coordinate plane, and you need to remember which quadrant is which. Can anybody tell me the number of this quadrant? What is this? Quadrant number what? 1. So if that's quadrant 1, then what quadrant is this? 2. And this is 3, and this is 4. When we rotate figures, they generally move 1 to 2 quadrants, depending on the rotation. If we're going clockwise, now in case you forget what clockwise is, it's the way the hands of a clock turn. So if you're looking at a clock, this is clockwise. That's the way that the hands turn around the clock. That's clockwise. So when we go 90 degrees clockwise, we're moving that figure 1 quadrant. Very important here, a 90 degrees clockwise rotation is the exact same thing as a 270 degrees counterclockwise rotation. What does that mean? I'll let you guys write that in real quick. Let me show you a quick example here. If we were to take this figure and rotate it 90 degrees clockwise, it would end up here, 1 quadrant away, right? We're rotating it 1 time around the origin. So it would end up here. If I were to rotate it 270 degrees counterclockwise, then it would be 90, 80, 270 degrees. So 90 degrees clockwise is the exact same thing as 270 degrees counterclockwise. The reason I show you that is because you can see problems that say 90 degrees clockwise or 270 degrees counterclockwise. Just understand they are the exact same thing. Now, 90 degrees counterclockwise, how many quadrants do you think we're going to move that figure?
1.
Still just 1 figure going 90 degrees. And once again, 90 degrees counterclockwise is the same as 270 degrees clockwise. Make sure you're writing this in as we go. Last thing is a 180 degree rotation about the origin. How many quadrants do you think we're moving? 2 quadrants. Important piece of trivia. A 180 degree rotation around the origin is the exact same thing as a reflection across the origin. And we did this last time. We reflected something across the origin. See who remembers. If you reflect something across the origin, let's just say I've got the coordinate pair 3, 4. If I were to reflect that across the origin, Sophia, what would the new coordinate pair be? If I were to reflect this, let's say this is point A, and I were to reflect that across the origin, what would A prime be? Negative 3,
Negative
4. Yeah. When we reflect something across the origin, you multiply both coordinate pairs by -1. So we multiply 3 by -1, you multiply 4 by -1, that would be A prime if we reflected it across the origin or if we rotated 180 degrees. All these things kind of start to flow back together. So if you know one of them, you can unlock the piece of the puzzle for the next one, the next one, the next one, and everything kind of falls into place. Does everyone have this written in? Yeah? All right, so let's see exactly what they look like when we rotate them. So we have 90 degrees clockwise around the origin. Notice that we're moving 1 quadrant. Like I said, 270 degree counterclockwise, same thing. So here's our pre-image. This is where we start. If I'm rotating this 90 degrees clockwise, which way am I moving it? Am I going to move it up 1 quadrant or to the right 1 quadrant?
Up 1 quadrant.
Up 1 quadrant. That's right. The pre-image would move 1 quadrant up because we're rotating it 90 degrees around the origin, and it would end up right there in quadrant 2. So we start in quadrant 3, we change the orientation, and our figure ends up in quadrant 2. Notice that when we rotate a figure, the position will change and the orientation of the figure will change. I'll let you write that in and I'll explain about orientation again just to make sure we're on the same track. Everyone have that written? Okay, so orientation is the way the figure is positioned in relation to the coordinate plane. If you were to pretend that this is an arrow, here it's pointing to the right. When I take this figure and rotate it 90 degrees clockwise, which way is the arrow pointing now? To the down. If I were to rotate it one more time, which way should the arrow be pointing?
To the left.
To the left. And if I were to rotate it again, which way would it be pointing?
Up.
Up. As you can see, and if we rotate it one more time, we'd end up exactly where we started. What about counterclockwise? Let's see if I can have you guys help me with this one. Now our figure is currently in quadrant 3. Let's go to 7. 7. If I was going to rotate this figure 90 degrees counterclockwise around the origin, right? It's currently in quadrant 3. What quadrant would it end up in? It would end up in quadrant 4. 9 degrees counterclockwise, here's my origin. If I'm going counterclockwise, I'm one quadrant to the right. Notice that the orientation changes. It kind of looks like the building fell over. And our image is now in quadrant 4. Whenever you're doing rotations, make sure that you identify, am I moving counterclockwise or clockwise? Am I moving to the right, to the left, up, or down? Once you do that, that's a good way for you to go back and check whether or not what you did algebraically makes any type of sense. Do we have this written in? Okay. 180 degrees clockwise around the origin. There's 2 ways that you can do this. Notice that our pre-image is in what quadrant? 1. So when I rotate it around the origin, it's the same as reflecting. 180 degrees, I can either rotate it counterclockwise, or I can rotate it clockwise. It doesn't matter which way I do it. I will still end up in the exact same position. If I go counterclockwise, I'm moving 2 quadrants, and I end up in which one?
Quadrant.
I end up here in quadrant 3. If I rotate it clockwise, I still move 2 quadrants, and I still end up in quadrant 3. My figure will end up here. Notice once again that the orientation will change. And what do we notice about this? We move from here to here. We rotate it 180 degrees. What does this look like? What else does this look like? Besides a rotation, it looks like a what?
Reflection.
A reflection across the origin. It's the exact same thing as reflecting it across the origin. 3 different ways to get there. Take whichever one works for you. And notice that our figure is now in quadrant 3. Any questions on this? Let's see if we understand what it is we're doing. I'm actually going to have some of you come up in a second to do this, so please make sure that you're paying attention when I explain this. We don't need a whiteboard right now. Here's what we're doing. I have an infinite number of shapes here. I have an infinite number of shapes here. I'm going to take one. Please make sure you're watching, so if I call you up, you know what you're doing. We're going to take one of these, and I'm going to put it here. I want to rotate this figure. We have 3 different types of rotations, right? 90 degrees clockwise, 90 degrees counterclockwise, or 180 degrees around the origin. So if I want to take this figure, you guys give me a rotation. What do you want to see? How many degrees? 90 degrees counterclockwise. So if I'm going 90 degrees counterclockwise, should I end up in quadrant 1, quadrant 3, or quadrant 4? Quadrant 3. So I'm in the right quadrant. I'm in the right spot. But what's wrong?
The dot.
The position's good. The orientation's wrong. So to fix your orientation, you will click the figure. See this little thing here that looks like a little twisty arrow? I don't know what the actual term for that is. It looks like that. You see that? This will allow you to fix the orientation. So when I orientate, which way did I go? Clockwise or counterclockwise?
Counterclockwise.
So should I rotate it this way or that way? To the left or to the right? The left. You tell me when I should stop. Stop. Is that correct? Yes, it is. And a quick way to check, orientation is good, a quick way to check the position is good, is notice that the corner of this square is located 1 unit to the left, 1 unit above the origin. The opposite should be true when I have it here. 1 unit to the left, 1 unit below. So I am in the correct position. Just be careful when you're doing it. So I need volunteers. We're going to do this. We're going to do the other 2 rotations, and then we'll work with my little pizza pie right there. Any volunteers who want to come up and do this? Andre wants to do one, and come on. I need a young lady. Let's see if I pull a card out. No? Okay, Maria G. All right, so Andre's first. Andre, come on up, dude. All right, so what you're gonna do is you're gonna click the figure. There's an infinite number. They're just dragging. Now, I want you start up here. You're starting here. This is gonna be your image, right? I want you to take that figure. I want you to reflect it 90 degrees clockwise about the origin. So where would you end up? Let's see. Okay. All right. So let it go, and then ask your classmates. Do you have it in the correct position? Yes or no?
Yeah.
Position's good. What's wrong?
Orientation.
Orientation. All right. So Andre, click the little twisty arrow thing, the little rotator, whatever it's called. Click the figure. Click the little rotation. There you go. There you go. And let's see. Rotate it till you think you have the orientation correct. And let's see. All right. Does he have the orientation correct?
Yes.
Yes, he does. We'll just fix that position up just a little bit. And perfect. Good job. Thanks, buddy. There you go. All right. Good job. Give him a hand. Give him a hand. Yes! Yes! All right. Give me a 180-degree rotation about the origin. However way you get there, it's up to you. So she's got the position. Is the position good?
Yes.
Yes. Let's check the orientation. You just click it and I'll click the figure again. Fix the position. Okay. And then just hold it. There you go. All right, let's see. Does she have the orientation correct?
Yes.
Yes, she does. All right, give her a hand. There you go. Okay. Now, why was this easy? Why was this easy? What made this easy? Because of the dot. The dot made it easy. It gave me a point of reference. I know that here I'm pointing up and to the left, up to the right, down to the right, down to the left. So let's remove these. And let's try pizza pie. This one's still not too difficult because I still have a point of reference. You can pretend this is an arrow, a pizza pie, something, but let's try to make it not so simple. Let's try to put it, where should I drop it? You tell me.
There.
Right there?
Right
Right?
corner.
There. Okay, we're gonna drop it right there.
I was gonna say.
We're gonna drop it right there, and then we're gonna try to perform all of our rotations on this. So, any volunteers this time? Not the same people. All right, I got Benitez, I got Miggy. Can I get a young lady? Can I get a young lady? All right, and I'll find a young lady. First young lady who comes up in the cards, Miss Pena. That's you. All right, so first things first, Mr. Benitez, come on down. Same process. You're gonna take one of these shapes. This is your pre-image. So you're going to take one of these shapes, you're going to pretend that this is your starting point, and I'm going to give you the rotation. Actually, your classmates are going to give you the rotation. What do you want to see them do? 90 degrees. 270. 270 what? 270 counterclockwise. Now, you have to remember, 270 counterclockwise is the exact same as, if you're going 270 counter, 270 counterclockwise is the same as 9 degrees clockwise, okay? So I'll help you out there. So go ahead, hold on, let's put it back on the arrow. Go ahead, grab your shape, and you got an idea of what you're doing. All right, so does he have the position correct?
No.
No, he does not.
No. It's doing the same position.
Is the position correct now?
Yes.
Yes, position correct. What's wrong?
No
Orientation. So click it, grab the little rotator, and rotate it until you think you have the right orientation. You gotta click and hold. Whoa, hold on. Whoa, hold on.
That's definitely wrong.
Alright, so we're gonna slide to this side. Slide to this side, come over here. Alright, so you're gonna click it. Once you click it, just click and hold the rotator, okay? Alright, so click and hold that rotator. There you go. And you stop whenever you think you've got the right rotation down. Alright, does that look good? Yes. Position's good, orientation. One of your infinite figures here, and let's rotate that. check the position. Is the position good?
Yes.
Yeah, position's good. Okay, you just gotta fix the orientation now. Alright, position's good. Alright, Ms. Pena, there's only one spot left. You know what to do, we're not gonna say it. We're gonna let you go ahead and rotate that figure for us. Alright, is the position good? Yes, now just fix that orientation.
Oh.
Alright, let's see. Okay. Now, two quick questions. Let's go to coordinate. When we rotate a figure, what changes? There's two things there. Give me one of them. When we rotate a figure, there's two things to change. Give me one. Orientation changes, that's one. What else changes? The position changes, let's see. Position, orientation, and somehow Miss Pena's figure disappeared. But alright, it's there, we know it's there. Position changes, orientation changes. Good job. There's one for you. There is one for you. And any questions on this at all? Any questions? No? Alright, so 4, 3, 2, 1 on this. Got nuts? Now, algebraic side. Once again, as long as you're able to multiply by -1, you're good. But you're probably still thinking to yourself, well, hey man, we're just multiplying these coordinates by -1. That's a reflection, dude. We already learned that, man. Why are you teaching us the same thing again? Nah. Truth is, the rules change slightly. When we're doing a rotation, here's the rule for 90 degrees clockwise. Now, I want you guys to write this in. 90 degrees clockwise is also the same as
270.
200. Write it in right here. 270. You can write in counter clock. Whatever works for you. I want you to write that in. 270 degrees counterclockwise. Same thing. Or you write CC. That works as well. Now, 90 degrees counterclockwise is the same as 270 clockwise. So you can just write 270 CL clockwise, whatever works for you. Same thing. But let's look at the coordinate notation here specifically. When we do 90 degrees clockwise rotation, we multiply the x coordinate by -1. Well, we've already done that when we reflect it across the y. There's one more thing. Only after you multiply the x coordinate by -1, you then switch the x and the y coordinates. So it looks like this, x comma y, arrow, y comma -x. And let me show you what it looks like when you do the actual multiplication. The multiplication is easy. After you multiply, you just flip the coordinates around. So this is going to be 90 degrees clockwise. Which coordinate do we multiply, x or y? The x. So we'll do that. We're going to do 4, parentheses, comma, -1, comma, 7. Notice the y does not change. So once we do the multiplication, we'll end up with -4, comma, 7. Okay, that would be great if we were reflecting across the y. There's one more thing I need to do. Once I've done the multiplication, what do I need to do? Flip the coordinates. The sign stays with the -4, so don't make it a -7, comma, 4. It will simply switch position. So instead of -4, comma, 7, we're going to have 7, comma, -4. 7, comma, -4. That is horribly drawn. Let me clean that up a little bit for you. So A prime becomes 7, comma, -4. Multiply and flip. That's all you got to do. Multiply the x by -1, then flip them. So here, we all know how to multiply by -1, right? All of us know how to do that? Once you do the multiplication, do not do this out of sequence. Once you do the multiplication, then you flip. If you do this out of sequence, you're going to end up with this, -7, comma, 4. Is that correct?
No.
No. If you flip first, then multiply, it'll be wrong. So you multiply, then flip, or then switch, whatever vocab word works right for you. Okay, so that's 90 degrees clockwise. 90 degrees counterclockwise, what coordinate do you think we have to multiply this time?
Y.
The y. If we do clockwise, the x. If we do counterclockwise, it's the y. So we have 0, comma, -3. Kavina, tell me. What's it going to look like when I do that multiplication? What am I writing? 0, comma,
-3.
well, parentheses, right? This is multiplication, okay.
Multiply by -1.
Okay. And then what does that become before we switch it?
0, 3.
0, 3. Okay, that's the first step complete. We have multiplied y by -1. Now what do you got to do?
Switch them.
Switch them. So what's your coordinate pair going to be for b prime?
3,
3, 0. That's the only change. That is the only new piece of information between reflections and rotations. After the multiplication, you're going to be asked to switch. And that's only if we're doing 90 degrees. If we're doing 180 degrees, remember that 180 degree rotation is the exact same thing as a what? Reflection over the origin. So in this case, you're simply multiplying the x and the y. Are you going to flip them? No, you're not. Did we flip them when we did the reflection? No, we did not. So this is the only time that you're not switching. When you go across the origin, or you do 180 degrees, you're just multiplying both coordinates by -1. You do not flip them around. So here I have -3, 7. So Ryan, what's that going to look like when I do the multiplication, bud? Well, what coordinates am I multiplying? The x, the y, or both? Both, okay, so we'll write our first parenthesis. What am I doing to the -3? I'm multiplying it by? No. -1. We're never multiplying by anything other than -1 when we do any transformations, okay? Unless we're doing dilations. We haven't done those yet. So right now we're just going to write -3, bud, multiplied by -1, comma. What am I doing to the 7? I'm multiplying it by -1. There you go. Do I flip these, yes or no?
No.
No, this is where people make the most mistakes. They start flipping these. When you do 180 degrees, you do not flip. Therefore, I can just go ahead and write my C prime. What is my C prime going to be, Gabby?
3, -7.
Perfect. 3, -7. Any questions on this? We got one more example, and then we're done. Almost there. We're actually going to see what this looks like when we do a rotation on the coordinate plane. Everybody have this all written in? And Colby's going to help me with this. All right, Colby, we got a figure. We got a triangle. W-A-R, war, or raw, or R-R, whatever you want to call it, okay? So, we want to rotate it. I'll give you the directions now. Just I do this so you don't work ahead. Directions are to rotate it 90 degrees clockwise. So the very first question, Colby, if I'm rotating this 90 degrees clockwise, this is a good way to check your work to make sure that when you do your algebraic rotation, you're in the right spot. If I'm going 90 degrees clockwise, I got 3 other quadrants here. Which one's it going to end up in? Fourth one. It's going to end up down here. So if you do all the math and you end up over here or over here, you know you did something wrong. Check your work. So Colby, 90 degrees clockwise. Tell me, looking at the rule, if I'm going 90 degrees clockwise, what am I multiplying? Which coordinate? Look at the rules. We'll go back. 90 degrees clockwise right here. Which coordinate gets multiplied?
X.
The x by? What are we multiplying the x by? By -1. So, let's do that. And that's going to give me, if I multiply the x by -1, what's that going to give me? That's the w. I'm multiplying the x coordinate in w by -1. -1, 1. Am I done though? No, I have to flip it. Therefore, what is my actual w prime coordinate? 1, -1. When you have that, you go in and you graph it. And that becomes w prime. So I have 1 point done. Vicente. A prime. Still 90 degrees clockwise. So which coordinate am I multiplying? The x by, what am I multiplying it by? -1. We're working with the a coordinate. So you tell me, after I multiply the x by -1, what coordinate pair am I going to have? Perfect. -3, 1. Is that my final coordinate of a prime? No, what do I got to do? Switch it. So what's it going to become? 1, -3. Beautiful. We go to the graph. We drop the point on the graph. 1, -3. 1, 2, 3. That becomes my A prime. Make sure when you're doing this, you label the points as you do it. You can do everything correctly. If you mislabel my vertices, I am going to count it against you. You have to do that correctly. All right. Any questions so far? Any questions? Okay. Thank you, Ms. Vicente. Last but not least, let's go to Mr. Benton. We got point R. We're going 9 degrees clockwise. So which coordinates get multiplied?
The X.
The X by?
-1.
-1. So after you do the multiplication, what's your coordinate going to be?
-2, 3.
Perfect. -2, 3. Now that we have done that, we need to switch it. And we're going to end up with what?
3, -2.
3, -2. And then what am I going to do with that point? I got to graph it. So we go to 3, start at the origin, 1, 2, 3, -2. Boom, boom, boom. And what's this going to be labeled, Miss Pena? R prime. R prime. I then go in and I connect all of my points with lines. Thank you. Lines, something or other. All right, we connect, we connect, we connect, and then we connect 4. Yes, and we still go back and we check our work. We say, okay, I did a 9 degrees clockwise rotation. Am I in the right quadrant? Yes or no?
Yes.
Yes. Is the position correct?
Yes.
Yes. Is the orientation correct?
Yes.
Yes. As I rotated, it should kind of flip over on its side. I did it good. And we know the coordinate pairs for WAR prime, and we're good. Any questions on this? Any questions? No? All right.